Hello, and welcome back to the final speedrun of today with me, Vince. So we're just going to be finishing up some of our exploration into histograms, so let's jump right in. So, the final thing we need to talk about is histograms with unequal class widths. So far we've been sticking to histograms that have equal class widths. But, you know, this isn't always the case. Because sometimes, if we have equal widths, it makes it hard to comment on what's really happening in the distribution. So, if we have such wide class widths, when data is not very spread out, but when data is very concentrated, it makes it appear very faulty. For example, this histogram and this histogram are, actually we need to lower these edges a bit, but these two histograms could be representing the exact same data, but with different class widths. So this one shows a much wider spread than this one, and so it can be misleading. On the other side, if we have such a low range of data, then very narrow histograms can be cumbersome and hard to use. Because an example is if we did like this, and then one large one, and then this again, it would also make it very hard to read. So, the two rules for the histogram would be that we want to make it represent the data well, and we want to make it represent that in principle, the area is roughly proportional to the frequency of the histogram. Now, sometimes this isn't the case, but we want to try and stick to those rules as best as possible. So let's jump into some final questions, not too much to talk about. So first one is a group of 25 females from Mexico were asked how many children they each had. The results are, and then we have a histogram. So at the top is 10, bottom is 0. And then along this axis, we have some discrete data, of course, because it's the number of children has to be discrete. So we have 5, 10, 6, 3, and 1. And I'm going to simplify this, just put the numbers above, 5, 10, 6, 3, 1. Just check that as it's 25, yep. So, first we need to show the mean number of children per female is 1.4, and, well, okay, let's just check that first. So we have 5 times 0 is 0, 10 times 1 is 10, 6 times 2 is 12, 3 times 3 is 9, 1 times 4 is 4. 10 plus 12 plus 9 plus 4 is equal to 35. 35 divided by 25 is equal to 1.4. So that's the mean. Now next, a group of 25 females from Australia were also surveyed, and the results are here in a table this time. So number of children and the frequency. So we have 0, 1, 2, 3, 4, 5, 4, 8, 5, 4, 5, 2. So we need to use this data over here and this data over here to describe the distribution between the number of children the two groups of females have. Okay, so I guess on average, let's just calculate the average number of children they have here, which is 8, 10, 12, 20, and 10. So 8 plus 12 plus 10 plus 20 plus 10 is equal to 60. So they have 60 over 25, or they have around 2.4 children per woman. So this is certainly a much larger number than 1.4. So women in Australia have more children than women in Mexico. What else is there to say about this? This looks like a bimodal distribution, something like that, although I'm not too sure exactly. Whereas the one in Mexico is quite unimodal and quite skewed as well. So yeah. And on to is this the final one already? Okay, I guess it's the final question already. So we have the height of 14-year-olds from Sri Lanka and Peru were recorded in the following table. And I'm going to simplify this to one table. So we have the height, and then this is Sri Lanka, height of students, the frequency in Sri Lanka, and the frequency in Peru. So we have 120 to 130, so this is continuous data, 130 to 140, 140 to 150, 150 to 160, and 160 to 170. So for this, we have 3 here and 22 here. Okay, 11, actually, I'll fill it out this way first. 14, 8, and 6, and 22, 40, 41, 32, 6, and 6. So first of all, we need to explain why it's necessary to construct a relative frequency histogram for the comparison, and it's necessary because these two data sets have different numbers of units or data. And otherwise, like if we didn't construct a relative frequency, it would be like, oh, people in Peru are much shorter than people in Sri Lanka because 41 is greater than 11 and 22 is greater than 3, even though they have the same amount at the highest height. But this is kind of incorrect because they're just generally more Peru students interviewed. So next we need to construct a relative frequency histogram. So let's draw it here on this axis. We have 120, 130, 140, 150, 160, and 170. And over here we have the relative frequency from 0 to 1. So let's draw this red for Sri Lanka. So actually, we need to know how many kids were interviewed in total. So this is 14, 28, plus 8, 30, 28 plus 8, 36 plus 6 is 42. So we have 42 total here. And over here we have 22 plus 41 plus 32 plus 6 plus 8. Plus 6 plus 6. So we have 107 total students here. So out of the 42, 3 out of the 42 kids in Sri Lanka were between 120 and 130, so that's around 7%. So I'll put this something like this. Next, we have 11 out of the 42 were between 120 and 140, so that's around 25, 26%. So it looks around here. Next, we have 14 kids out of the 42 were between 140 and 150, so that's around 33%. So I'll put that as around that. Next, we have around 8 kids out of the 42 were between 150 and 160, so I'd say that's around that height. And finally, we have 6 kids. Actually, I need to lower the height of this one. This one's way too high. And so 6 kids means around that. So next, what do we have for Sri Lanka? For Peru, sorry. So you have 22 out of 107 kids. So that's around 20% were between 120 and 130. Around that amount. Actually a bit less. Next, we have 41 kids out of the 107 who were between the next two heights. So actually, this is a large amount. It's even taller than the earlier value, around that. Next, we have 32 kids out of the 107 were from this middle height. So 32 is around 30%, so it's like around there. And then finally we have 6 and 6. So 6 over 107 is around 5%. So it's even less than the other two. So what can we comment on this distribution? Well, clearly the height of children in Peru, 14-year-olds in Peru from the sample, was much lower than the height of Sri Lankans. The Sri Lankan height also had a much more even distribution compared to the height of the Perus, which was skewed to the left quite a lot. But both of them are quite unimodal distributions. So yeah, that was all for today. I hope you enjoyed the speedrun, and I hope to see you in the next